Now I'm going to give you a quick summarize of the first topic, which for most of you, I understand you already done physics in the high school. So this is for you. To be honest, from week 1 to about week 4, you will find the material is very similar, maybe even exactly what you have already learned in your high school. So I will say week 1 to week 5, the material shouldn't be too challenging. And when it moves to some advanced topic, it will be more challenging. And also in this topic, I will use the symbol and the notation of calculus, but I will not ask you to do calculus in your calculation. It's just I use the idea. So this is the mathematics, the requirement. All right. Now, in order to describe anything in physics, we assume something called the point. It means you have a point represent a car, represent rocket, represent machine. Now, in order to describe it, you have a coordinate. You have a 2-dimensional or 3-dimensional coordinate. Now, in terms of 2 dimension, we use x and y. In terms of 3-dimensional, we use x, y, z. Now, the x, y, z here, the x, y, z, there's a we call the right-hand rule. Now, how do you determine? For example, here, if I say this is a coordinate to describe a fly, a mosquito in this room, and this is my 0 point, how will you determine which one is x, which one is y? This is not arbitrary. You have to follow a rule. Every engineer uses this rule. The rule is like this. If this is your x, this is your y, this has to be your z. You cannot do it this way. You cannot say x, y, z down, okay? But this is we call the right-hand rule. Now, it means if you don't like this is x, yeah, I can rotate, I can do this, maintain x, y, z. See the order. So the order cannot change. X, Y, Z, but how you rotate this one could change. The same idea. If you look at the mirror, if this is your X, Y, Z, you cannot do it because this is you cannot align this properly. So use right hand only. We call the right hand coordinate system. We want a position. So we have a number, but most of the time we also want to change. Whenever in physics you see this symbol, you all say delta x, it means the change. This means change. Whenever you have a delta x, now there's a different way to write the change. Some people write final minus initial. It's fine. Some people write x minus log. It just means this is the initial. So look at all the materials. They are sometimes very different, but you have to know this is the initial, the meaning, and this means final. Always when you do change, you always do final subtract initial. Say for example here, if this one is x2 at 60 meters, x3 is in 260. So the change is final minus initial. So it's 200. Now how about x3 to x, if it go back to here, if it go back all the way to the 0 point, so this is your initial, this is your final is 0. So how would you do it? So if you have initial, say again, if this is your initial position, is you go all the way back to the original point, how do you do the change? The change is always final minus initial. So this time the change is negative 260 meters. The meaning negative here has a physical meaning. It means the final position is on the left-hand side of your initial position. So in physics, positive and negative always carry physical meaning. So in terms of change, if you find the change is negative change, it just means your final position is on the left-hand side. All right, as I say, this is summarized here. Now, this is, look at this number, this question. Can we look at A to E? I let you think about in about 1 minute. Okay, let's look at number 1. Distance traveled can never be negative. Now, in this case, I want to tell the difference between distance and displacement. Now, distance means if you have an object here, if you go here 2 meters, you come back here in the original, so the distance is 4 meters. But how about the displacement? 0. All good. So distance traveled can never be negative. Can you have a negative distance? No. So this is true. Distance traveled is always equal to displacement. False. Distance traveled is always less. Always less. If I have a from here to here, so I go here, so the distance is 2 meters. How about displacement? Would it be always less? You remember sometimes 2 and 4 in examination, this is where the logic. So there's a false because it could equal. It could equal. You will lose mark in the exam already. And distance traveled is always more than false because it can be equal. Distance traveled is greater than or equal than true. Now, this is not just physics, it's about the language or the logic. So be careful in any exam situation. Velocity and speed. Remember, we say velocity is defined as, put it this way, speed. Speed is defined by the distance over time, where velocity is defined by displacement over time. Now, all this definition is average. It means we average for a long time, for a period of time. So what is long, what is short, I cannot tell, but later, usually you have to go to some mathematics. Now look at this table. If you look at how the motion of a runner, so this is at 0, position 0, 1 second, 4.5. So all you need to do is plot the position versus time. Now from here, if you plot the position versus time, you can see, you can get the average speed. So how will you do it? You just look at here. If you're saying you want the average speed for the first 2 seconds, so you ignore the first second. You just lose this point, and you look at here, here, and here. So this is your average, the change in displacement, and this is your change of time. Can you see? So the average over 2 seconds, your speed is delta x over delta t. It is the slope here. Now can you see, if you want to take an average, it really, if you just say, if you take the average from here to here, if you take the average from here to here, can you see the difference? So the rule is, if you take average usually mean you lose information. If you just take the average from 0 to 3 seconds, you really don't know actually come from here and pick up. You lose this bit of information, totally lost. So the idea usually is, in order to know more about the motion, you want to make the average, the interval, what? Shorter, and shorter. The more data you get, the shorter the time interval, the more you know about the motion. So this is the basic idea about motion, is you want the interval. Now skip quite a bit of this because you should already know. So the idea, now in one dimension, in the case we just did, be careful about if I say this is a velocity, I mean this is displacement. If I say this is speed, I mean this is a distance. So you have to understand the word and how you do it. We already know how to distinguish between displacement and distance. What happened is, we want to make the time interval smaller and smaller, such that we know more and more, and we see the average velocity here is changing. So you get more about the motion. So graphically, this is what you do. This is where the idea of calculus. If you original here, and T1 and T2, so when you do the average, you are saying is at T1, I know this is your position. At T2, this is a new position. So this is your delta x, this is your delta t. So the average velocity is delta x, delta t. Now, as I say, you lost information. So what you want to do is you want to push this T2 closer to T1. Graphically, you want to push this point to here. So now this is your new average, but this time your time interval is smaller. You keep pushing it until this is so small. This is where the mathematics say you want to push this one such that the delta t approach to what? 0. This is we call instantaneous velocity. The velocity at this point. So velocity usually is a time interval. But if you push the time interval to 0, now you're saying this is 0, but we've got a non-zero number? Yes, because this approaching doesn't mean 0. Approaching just means very little. This also very little. And the ratio of these two numbers will be a non-zero number. You cannot say 0 over 0 or 5 over 0, for sure it's not. But limit, yes, you can. So this is all the idea of calculus actually derived from the need of physics. Okay, this is the idea. So you see at this point, if this is the instantaneous velocity at T1, at T2, this is at T3, this is now. So can you tell which one, T1, T2, T3, has higher velocity? So the idea is T1. In terms of ratio, T1 is higher than T3, higher than T2. Why? Because it's now become, you draw a tangent, and then you find the slope of this tangent. This is the instantaneous velocity at this point. So some students, when I was young, I think, why tangent? And is it you can only draw one line? Can I twist a little bit, draw this one? The answer is no. I let your math teacher convince you. At any point in the curve, you can only draw one tangent line, no more than one. If you argue, you shift this one a little bit, this is not a tangent anymore. This is we call a chord. So tangent is only one. It means you are looking at draw the tangent, find the slope, and then it means the instantaneous velocity is only 1. You don't have more than one instantaneous velocity. All right, so as I say, I only focus on the concept. Speed is the same. And okay, look at this one here. This graph shows the position of a car going forward and backward. You see, now the thing most important is how to interpret this graph. What this graph say is at 0 point of time, you already at position what? 5. So you are not at the origin. Now, when the time goes, you are moving to the positive side, but after 2 here, what happened? You stop and actually you go backward. Now, how do you know stop? When I say stop, stop means velocity equal to 0. This is the meaning of stop. Now, in graphically, it means if you plot position versus time, is where the tangent at this point equal to 0. So therefore, I will say roughly about 2 seconds, it stops. Now, if I ask you, identify the time where the car instantaneous is positive, negative, and 0, let's do it. Now, usually the way is find the 0 first. So this is 0, this is 0. Can you see it? So it means at 2 and 6 velocity equal to 0. How about from 0 to 2? What is the sign of the velocity, positive or negative? Now, it's all point here, so it's a positive. This is negative. So it goes this way down, so it's negative, positive. Yeah, this is the way you do it. So usually for this sort of question, is first identify the 0. And in between the 0, usually either all positive or all negative. And depending on which way is the slope, the sign of the slope. So this is all you need to do. Okay, look at here. Sometimes you want to get the idea, the plot from position to velocity. So if I say this is the position graph, which one should represent the velocity, the instantaneous velocity at each point? Now remember, the first thing is look at what the 0 first. Let's look at the position here. At which point you got 0 velocity? This point. So it means if you look at now the way to do it, forget all the one at the bottom. Let's see if nobody show you this one, how you're going to do it. I will do the velocity here. At this point, now this is t, this is the velocity v. At this point is 0. So sorry about it, at this point is 0. So you go here. So the velocity at this time is 0. So where you should put the velocity point? 0. Can you see it? So therefore, you identify the 0 point. Now, from this onward, can you see this is positive or negative? They're all positive. So you don't know whether it's a straight line or not. You just casually say this could be positive. From here to here, they are negative because the slope here, the slope is positive. The slope is negative. So the value, you're talking about the slope. So this is negative. I don't know, but it's just plotted. So therefore, which one should be the answer? It's not here. You don't have here. It gives you a straight line. Yeah, okay. There's only choice. So if you're given this, to be honest, you don't know. You cannot tell it has to be straight line because you don't know this is a parabola. So, but fortunately, you only give one, and this one has a 0 point. So you see the 0 point here gives you the answer. So the answer in this question is D. Any problem? Okay, go ahead. Acceleration is the same. This time we look at the change of the change. So velocity is the change of displacement. Acceleration is the change of velocity. So you can do the same thing, the same argument, and you put versus this one, and you will get the instantaneous acceleration. So this acceleration is changing as well. So the same mathematical formula and the same average and instantaneous. The unit meter per second square. So it's all okay. I think about one thing I always say is the word deceleration. You see sometimes some teachers say a car is decelerating. Have you ever heard this? Now this is very confusing. So I need something. I usually I have my tennis ball with me. Anyone got a tennis ball? No, you won't. Anyone got an object which I can I need something. I don't want your mobile phone. It will drop. Okay, this one may do. Okay, thank you. Now, for example, I have an object here. Usually I use tennis ball. Now, in order to describe a motion, the first thing is coordinate. Make sense? Now, if I say my hand here is 0 point, what is the second thing you need to do? Set up the direction. Now, which one should be positive? Which one should be negative?
You choose.
I choose. Good point. I'm the teacher. I choose. Now, in reality, you can choose. Most likely, up is positive, down is negative. But if you say, are you able to choose down is positive? Yes, as long as you stay clearly in your drawing. But if you don't follow everybody, up is positive, down is negative. Okay. Now, if I throw this one up, okay, no variable things. Good. If I throw this one up, this one will go up and come down, okay? Now, when I go up, this one goes up, it already got so-called initial velocity. So what is the sign of the velocity? Positive and negative. Why positive? Think about the definition. At time equal to 0 is 0. For example, at time equal to 1 second, it moved to 0.5 meter. Positive 0.5. 0.5 over 1, positive over positive is positive. So whenever you goes up, this is positive. How about if someone this time, this is 0 point, if you throw this one from here to here, what is the velocity? Positive and negative.
Positive.
How do you describe now? I will say the position, the initial position is negative, but the velocity is positive. Why? Because of displacement. For example, if this is at 10, minus 10, after some time minus 5. Remember, minus 5 minus 10, positive. So this is, it doesn't matter where you are. Its matter is where it's heading to. You can have a negative, positive domain. As long as you head to the positive side, it's positive velocity. Got it? So it's not where you are, it's where you're heading to. Determine where the sign of the velocity. So put it this way. Now, I always say the problem can be reversed. If you know the velocity is positive, do you know where it was? Think about the reverse question. If you know the positive of the velocity of the object is positive, do you know where it was in terms of position? You don't. Think about this case. It could be here. It could be here. It could be here. So it again is the information. Got this point? If you know velocity, you don't know position. You don't know position. Got it? So when you really work out the position, the only thing you know is we call the displacement, how much it moves. But it can be from here to here. It can be from here to here. It can be from here to here. You got a number. So remember, when you do mathematics, when you do an integration, after your integration, usually your math teacher asks you what to do, plus a constant. this constant will fix where you are. Got it? So therefore, integration, after you finish the integration, find the distance, you only get how much you move. You don't know where you're actually from. Now think about from now on what information you get from. Okay, acceleration. Acceleration is the change of velocity. When the journey goes up, the velocity actually reducing. Make sense? So I actually can tell at the highest point the velocity is equal to 0. So remember the rule, the second rule, whenever an object turns, the velocity at the moment is 0. Can you remember this rule? When the object turns the direction, the moment has to be 0. So when it go to the highest point, it go up, turn, at this point, the velocity don't need to think about it, 0. Just like if I practice my running tomorrow, I stop when I turn back to home, the moment I turn back, my velocity has to be 0. So the second rule you have to remember now. So the velocity reducing. Now, but the velocity reducing, what is the acceleration, the change of velocity? Now, let's put it this way. The change is always final minus initial. So let's look at the initial. Initial is 1 meter per second when I lift this one. And the final is 0. So what is the acceleration? Positive and negative? Think about initial is positive 1 meter per second. When it goes to the maximum height, the velocity is 0. Remember, whenever I say change, has to be the final minus initial. Final is 0, initial is a positive. So the number is negative. So it makes sense now? Yes. So when you, now the rule is like this. When you put something, so therefore the acceleration is negative. Now how about if this one drop back? How about the acceleration? This is the negative again. Why? Let's see it. At this point, maximum height is 0. But how about here? At the moment I catch it, positive and negative velocity. Positive and negative. It's going down. Remember I say, it's not where you are, it's where you're heading. You're heading to positive, so all the way up the velocity is positive. All the way down, the velocity is negative. Make sense? It's heading to the negative direction. So when you throw something up, all the way is positive velocity, negative velocity. Now how about acceleration? We just work out when it goes up, the acceleration negative. How about it comes down? Look at it, 0. Negative 2 meters per second. Negative 2 meters per second minus 0. Positive, negative? Negative. Got it? So, because remember I say you always subtract from the final and compare the initial. And the initial, when I drop this one is 0. And when I receive this one is negative. So negative number subtract 0 is also negative. So what it means, during the whole journey, it doesn't matter it goes up or comes down, the acceleration always what? Negative. And you know the acceleration, the number is 9.8 meters per second square. And always negative. Take this point now. Now is it convincing now? Now once you put the number, I always say physics always about visualizing, always number. Now you always accept this. You may remember in your high school teacher told you. Now I hope you're really convinced this is really the case. Now going back this one, the word about acceleration. So if I ask you a question, what is the acceleration during this journey? What is the acceleration? Acceleration. Acceleration. I just used the word acceleration. What is the value of acceleration? Positive or negative? Why? Because it pointed down. So the acceleration vector always down negative 9.8. It doesn't matter it goes up or comes down. Got it? Now, how about velocity? When it goes up, positive. When it comes down, negative. Okay, how about speed? When it comes up, the speed, now speed always positive, remember. But I want to think about the speed. Is increasing or decreasing?
It's decreasing.
Decreasing. How about the speed? Increasing. Therefore, the word deceleration actually is focusing on the speed. So I can say now I summarize what I say, okay? If I use the word velocity, I will say when it goes up, positive, comes down, negative, like velocity. If I want to focus on acceleration, it doesn't matter it goes up or comes down, always equal to negative 9.8. Make sense? If I want to focus, use the word deceleration. It's tricky now. Usually people will say it's slowing down, so it's decelerating. So decelerating is a special case when the speed is reducing. And usually what happens is the velocity vector up and the acceleration vector down. Got it? So if the velocity, the vector, you know the idea of vector, is going up, the acceleration down, you're opposing it. So the vector will slower until it reaches the what? 0. So in this case, because you're opposite, we say this is decelerating. So decelerating is sort of not the best way in science. The science, you don't need to worry about deceleration, or you just say acceleration equal to negative. Got it? And if you know the velocity, acceleration, the opposite, you know is slowing down. In this case, you can use the word deceleration. But when it comes back here, can you use deceleration? No. So some people will confuse. They say, deceleration and acceleration. They just mix up the two concepts. So the best way, as I say in science, keep using one word, acceleration. And you use the sign, positive and negative. How do you know it's slowing down or speeding up? It depends on your velocity. If your velocity is opposite to the vector, it's slowing down. If they're parallel, speeding up. Can you see how I describe it? I use the word speeding up or slowing down. I hope you will sort of get this idea, especially in science, in physics, all about the language, or about how we describe the motion. And this is the key of today's lecture. I will keep going.
Yes, sir. If the object is parallel to what?
Sorry?
You said if the object is parallel to something.
Now, we have two vectors, in terms of vectors, velocity and acceleration. Make sense? If they are anti-parallel, when it's anti-parallel, when the object goes up, sorry, this is yours. When the object goes up, the velocity point this way, got it? The acceleration, down, so they're opposite. In this case, you know it's slowing down. It means it has to be. In this case, you can use, in this special case, you can use deceleration. Got it? When it drop here, so don't worry about positive, negative, it's the parallel. When this one drop here, the velocity down, the acceleration also down. So they're parallel. So in terms of speed, you know it's picking up speed because the acceleration help him increase the speed. Got it? So you're all visualizing. You see in the space, there's always a vector called acceleration in our force. Why it always down? If you look at from the Newton's law of motion, because the gravity is from the downward. You try to draw things down. So the force and the acceleration always parallel. And if the force is down, the acceleration always down. We already worked out it doesn't matter. This one goes up or comes down. If you look at the number always down. Make sense now? Thank you.
Sir, you dropped the coin.
Oh. Thank you. All right. So deceleration is the decrease in speed. When it happens, when the acceleration, when this one V here, this is where deceleration. And if you're here, now sometimes people will say this case is acceleration. It's a bit confused. Actually, both up and down is acceleration. Make sense? It doesn't matter it move up and down because always it's negative 9 points. So you cannot say it move up is deceleration, comes down is acceleration. It's wrong if you think this is wrong. But if you say the speed when it move up is decelerating, it's slowing down, the speed, the number is increasing, this is fine. One-dimensional motion with constant acceleration. This is, again, now, as I say, this is a revision, but I know most of you already know a lot of topics here, so I just usually focus on some confusion. I know students always find confused, and the rest I just skim through. Kinematic equation is used to predict the future. And now there's a different version, unfortunately, different book you make from a country, they use a different notation. You will see this version usually you find from the UK style, okay? They use the U, in this case, for initial. They use the V for final velocity. They use S for displacement, unfortunately. I think it's all right. And A of 4 for acceleration. But I know some of you may use V, something like this, or just V, and this 0 plus AT. Some of you may do it. Some of you may do it like this, D equal to VT plus half AT squared. Some of you may do it like this. All right. Now, what happened in the exam? In the exam, you write whatever symbol you feel comfortable. Remember, you are not, because as I say, both systems, everybody should know in the profession. So make sure your teacher also know. So I'm happy you know whatever symbol you find more comfortable. I can following your argument, and it doesn't matter. You don't have to follow my symbol. I use the traditional you usually find in a British textbook. In the American textbook, this is usually what you find. So be careful, sometimes we do have different symbols. I keep skipping, unfortunately, because the time. Now, the three kinematic equation, I always say, please memorize it. It means whenever you see a problem with, you always write down, this is how I will do it. Now, I'm sure I only spent about 15 minutes to write down this. The reason is, when you see all three equations in front of you, it's a lot easier to work out the problem. So don't think you can think it in your head. This is my recommendation. And now, it just categorized in different special cases. It's not very, I don't think this diagram is very important. First of all, A has to be constant. It means, for example, A is negative 9.8 meters per second square. Now, if A is not constant, is this three equation valid? Remember, no. If A vary, all these three equations won't work. So can you suggest a situation A is not a constant? We all know we throw the ball up and down, the A is constant. 9.8 meters per second square, negative. Any idea you know the A is not constant? Any? Air resistance, yes. If you include air resistance, the wheel acceleration will not be constant. Another thing is a little bit more complicated. We come back to this point. If you have a spring, Hooke's law say if you stretch your spring, the force you stretch is proportional to the displacement, how much you stretch. Make sense? Now, the force is F equal to ma. So the more you stretch, the more the force, the more the A. Can you see it? So it depends on where you release your spring. If you release here or you release here, the acceleration will be different. And if the spring come back here, the acceleration keep reducing. So in this case, if you have a spring, the acceleration itself is not a constant, it's keep reducing. Can you see the tricky thing? In this case, note all the three equations you are not going to use. You have to use a more complicated integration to find the equation of motion. This is usually we say sinusoidal. It means sine or cosine function. All right. If the velocity is 0, if also at rest both is 0. If the velocity is not 0, this is what you get. And if this is velocity is not 0 but not at if the acceleration is 0 but velocity is not 0, so it means you have a constant velocity. But if the acceleration is non-zero but constant, this is what you get. All right. Now this is special graphing. Graphing is important in physics. And acceleration versus time, this is all 0. So the acceleration is 0. And how about velocity? The velocity is also 0. In this case, it means it's at rest. It's not moving. So you have to look at this graph until you first look at the y-axis, look at the x-axis, and say, you're telling the information about the displacement. If this is not changing, it means this is at rest. If you look at this is velocity and time, how to represent something at rest, you have to use a velocity all 0. Can you see it? So both these two graphs is very good to represent, something at rest. But can you use this graph to represent something at rest? No. Because you only know acceleration is 0. It can move. It can move. It's just not accelerating. So this is two graphs represent something at rest. How about if you want to represent it's moving at a constant velocity, what happened? So in the displacement versus time, it's a strict line. What I mean is you look at the slope, you look at the slope, you look at the slope, they're all the same. So the velocity is constant. Therefore, if you plot the slope of this one, this is all constant. Now, because this is all constant, the acceleration also all constant. Can you get it? Now, this is the two graph. The two graph represent you're moving at a constant velocity, including this one. How about this time? Your acceleration is constant. This is how you see acceleration is constant. And your velocity this time become a straight line. How about displacement? It's a parabola. Okay. In terms of calculus, it just means because now I do a little bit here, don't worry. Here, and acceleration is equal to F over m. It's a constant. Remember, acceleration is, in terms of calculus, is this symbol. Agree? So dt, all right? So this is your velocity. Now this one is F over m. F over m is what? Is your acceleration. So you can write this one is acceleration, and this one is your t. So u equal to at. Can you say it? Now v is going back to here. You replace v by this one, and now dx or x equal to dt, and you go here, x or s, in our case I use s, equal to what? Half at squared. Of course, you have to add the constant, and this is the constant you need to add. Now, don't worry about it, and your math teacher will go through all the math to you, but I just want to say you can always understand by math or by graphic. All the three graphs, if A is constant, this is the constant, this is the velocity, and this is here. So usually we say if you know from A to velocity, you do integration. Now integration means the area. For example, if I want to know from here to here, at this point, what is the velocity? You just find the area here. And then you say this area corresponding to this velocity. So this point tells you the area underneath. If I want to do further the velocity, so you get a larger area, you always start from zero, always start from zero. So I say again, this is your initial. So this is where your velocity. You find if you move here, this is your area from 0 to here, so it's increasing. So can you say it's increasing? And if you all the way back to here, it's even further. Can you see they're all, if this is A, this is 2A, and this is 3A. So this is 1, 2, and 3. So they're linear. Now the same argument from velocity to displacement, you also do an integration. You also integrate. So from here you integrate your acceleration. This is your velocity. This is your displacement. When you do integration here, this is your area. But from here to here, you have a more area. So this is a non-linear. This is a non-linear. It's not a straight line. So the more you do, it's not double. This is linear. This is non-linear. Can you see it? So the distance is, what it means is, when you drop an object, if the first second it dropped 20 centimeter, another second is not another 20. It's what? More than 20. It could be 60. Make sense? So it's not proportional to the time because the acceleration. This is where you mean this curve. It's a parabola in mass. So how about from the other side? If you come back to here, you know the distance. All you need is find the tangent, find the slope, and use this value, plot here. The same idea, find here. Can you see the slope here is higher than here? So the value of the slope is higher. And this is your velocity. Now you do the same thing from, so this is a differentiation. And this is again differentiation. If you come here, you do the slope, is here. You do the slope, the same. Therefore your acceleration the same. Can you see the mathematics, how the mathematics link to the physics? All right, as I say, I have to skip a lot. This is a good question. It's coming, I think you will find similar question in multiple choice. The positive versus time, now this is, the first thing is a highlight circle, what the y-axis and what the x-axis it is. And what is the position? So the position here is 2, 6, 10. 2, you read here, at 2 is 10 centimeter, at 6 is 20 centimeter, at 10, you width here is 40 centimeter. What's the object's velocity during the first 4 seconds? The first 4 seconds is here. So this is your delta t. It changed its position from here to here. because your position. So with this one is 20 centimeter. So this is 0 and 4. So therefore, the velocity is delta x over delta t. Delta is always final minus initial. So it's 20 minus initial. Final is 4 seconds minus initial second. So therefore, in terms of centimeter per second, it's 5 centimeter per second. I think it's fine, but preferably you can convert this one is 0.05 meter per second. What's the velocity? What's the velocity? Got it? Now, do I have, okay, this is interesting. Read this question. Give me the answer. Okay, at the instant when t equal to 1 second, which one a is, the velocity of A is greater, less, or equal? Greater. Yes, because at this point, the slope is greater. So this is greater. Do object A and B ever have the same speed? Speed. What does speed mean? The slope of this graph. Do they have the same slope? Slope. No. Slope. This is distance versus t. All the way, can you see all the way have the same slope? All the way have the same slope. Are they equal? No. So their slope never equal. It means their velocity never equal. Make sense now? Now you see the wording. So the best way is translate. I always say the difficult about physics is how to translate this one into mathematics. So once you translate this one is, if you confuse B, all you need to say is, all you need to find is whether they have the same slope all over the time, over this time period. No. So they never have the same speed. But what happened at this point? Can you interpret it physically? What happened? Not the same distance, yes. Not they travel, because initially from 2 to 3, so over this period it only moved 1 meter. But from here to here, the blue, the A, moved how many meters? 3 meters. So I wouldn't say they travel the same distance, but they meet each other. So how do you interpret this graph in terms of a car? I will say when you start the clock, the car A is at 0 position. But the car B, now positive, negative is a 0 position. Car B already ahead. Make sense? But the velocity of A is higher than velocity of B, so it's catching up. At time equal to 3 seconds, they are at the same position. And then they are moving it. Now, if I give you this graph, can you describe this story? Yes. This is what you need to learn. You read a graph, you visualize it. You see what this graph wants to tell you. This is all about science and engineering. Most likely graphing is important, and you should visualizing what it represents. 3, 4. Now everything is the same in terms of mathematics. The only thing I want to highlight is when you write this equation in a general form, when you set up your equation, when you know this is positive, this is negative, when you drop something here, the acceleration is negative 9.8 meter per second squared. So you can just substitute. For example, I drop from 0. This becomes negative 9.8, and this is the t. Make sense? This is how you do substitution. But sometimes I don't really like, but some people will write g in terms of g. So the thing is, some people write this one. In this case, it's wrong. You should write negative g. What I mean is, if I ask you what is the value of g, how will you answer? If I ask you what's the value of little g, the value of g is 9.8. It's a number. It doesn't have any sign. But if you set your coordinate, this is positive, this is negative. The value of g is still 9.8, but the value of acceleration is negative g. Got it? So because the coordinate, you positive, negative, so the acceleration is negative g, negative 9.8. G is just a number. If you insist you set a coordinate downward, it's positive. In this case, your acceleration is g. So it's all up to, but the value g is always 9.8. Make sense? So it's the acceleration you depends on your coordinate. You put positive and negative g. So it's another confusion. A lot of students confused about all this. The rest is just simple mathematics. I won't spend time. Okay. Which diagram represents velocity versus time for a rock throw up and down? So the same, which one I should, if I borrow this one again, which one should represent I throw an object upward from the ground B. And come down? Remember, we already done it. When this object, do you want your iPhone or mobile phone, that me? You don't. If you throw the object, what is the initial velocity? Positive or negative? Positive. When it reach here, the top, zero. When it come back, negative. So which one? A. Originally, it's negative, okay? It's positive. So it's go, this one go. So either this or this. But there's a 0 point, but after you go to the maximum height, it's negative. So the answer is D. You see, it's so easy to forget. So probably already tried A, B, C, D. Okay, we finished today. It's